Hello everybody and welcome to 9.1 Pythagorean Theorem. The essential question is, how can you use the Pythagorean Theorem to classify a triangle as acute, right, or obtuse? What you're going to be learning is how to use the Pythagorean Theorem, how to use the converse of the Pythagorean Theorem, and how to classify triangles. Okay, so what we have here is a sample of what the Pythagorean theorem is. So in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Okay, so basically what that means is we have this side A of the triangle. If we take that to the power of 2 and we add that to the side B, the bottom part here, and we square that as well, both of those areas will equal to the larger area of the side C. And this is the Pythagorean theorem. A Pythagorean triple is a set of three positive integers, a, b, and c, that satisfies the equation c squared is equal to a squared plus b squared, which is the Pythagorean theorem. So basically, we want to have three positive integers that if I substitute them into the equation c squared is equal to a squared plus b squared, okay, we are going to get a true equation. So for example, if I substitute 3, 4, and 5 for a, b, and c, so a is always the smallest number, b is the middle number, and c is always the largest number. So if I substitute these values in here, c is the largest number, which in this case is a 5, so I have 5 squared equal to a squared, which is the lowest number, in this case we have a 3, plus b squared, which is 4, so I have 4 squared. Alright, so then I have 5 squared is equal to 3 squared plus 4 squared, so now I just have to simplify everything. 5 squared will give us 25, 3 squared will give us 9, and 4 squared would give us 16. Okay, so what happens here then is we just add these two together and we get 25 is equal to 25. Okay, so that's a Pythagorean triple because this equation became true because 25 is equal to 25, and all three numbers are positive integers, and that will work for all of these. These are the most common Pythagorean triples. If I substitute these into the Pythagorean theorem, it'll become true, which makes them Pythagorean triples. Now, their multiples also will become true and be Pythagorean triples. So if you notice that this line that I just circled here is basically the first row, the bolded ones, multiplied by 2. The third row here is everything up at the top multiplied by 3. And then the bottom row is everything multiplied by x. So any multiples of any Pythagorean triple that you know of or find will always be true for the Pythagorean theorem. Okay, so what I want us to notice here, we're about to use some numbers from this set of Pythagorean triples. So take a look at those, and then we're going to go ahead and go here for this example of how to use the Pythagorean theorem. So here we have a combination of 5, 12, and we're missing the longest side of the triangle. So if we go back over here, we notice we have 5 and 12. Okay, so then that means that the largest number, or the largest side of the triangle, has to be 13. So here in this case, x is equal to 13. Okay, we know that because I've given you the Pythagorean triples, but let's say we were not able to find that. So what we're going to do is we're going to substitute these values into the Pythagorean theorem. Let's say we have a squared plus b squared, and that's equal to c squared. Okay, so then let's identify the parts that belong to the formula. So we said that a is the shortest side of a triangle, so this side is represented by the number 5. So I'm going to do 5 to the power of 2. Next, I'm going to replace the b. b we said was the middle side of the triangle, so the medium length of the side, or the larger leg of the right triangle, plus 12 squared. And then that's going to be equal to c squared, which is the hypotenuse or the longest side of a triangle, which in this case is an x. So let's go ahead and replace the c with x. And then what we're going to do here is we're just going to simplify everything. So 5 squared will give us 25. 12 squared will give us 144. And then x squared, well, we're going to keep it x squared because we don't know what it is. So here we have our next step is the addition. So we're going to add this here to give us 169 is equal to x squared. Okay, now here is where we're going to find this value of x. Okay, so what we're going to do is we're going to eliminate the exponent, which we do by taking the square root to both sides of the equation. That will eliminate or be the inverse of the exponent 2. So then that's going to leave us with x is equal to, and then if we take the square root of 169, we're going to get 13. Okay, so this would end up being this side, as we had originally stated by using the Pythagorean triples. Alright, so x is equal to 13 in this case. Okay, this one's a little bit different. In this case, c has been given to us, so we know that c is the longest side or the hypotenuse of a right triangle. So we have this side here, which is equal to 14, and in this case we are not given this longest leg of the right triangle, which will be represented by b, and then the shortest leg is 7, so that's what we're going to be doing right now. So we should have 7 squared plus x squared is equal to 14 squared. Alright, so we're going to go ahead and solve this out by multiplying and finding our exponents. So here we have, change the color here, 7 squared is 49 plus x squared, because we don't have a value, for x, and then we're going to take 14, raise that to the power of 2, and that's going to give us 196. Now, so here what we're going to do is we're going to have to isolate our x value. So x has to be left alone, so we got to get rid of this 49. So we do that by subtracting 49 from both sides of our equation here. Alright, so then that's going to give us, leave the x by itself with the exception of the exponent, and give us, let's change this, x squared will then be equal to 147. Okay, and we're going to solve this just the same exact way that we did it on the other one, and we're going to take the square root to both sides of the equation so that we can isolate the x, which cancels that out. Take the square root of 147. I'm having some technical difficulties here, but here we go. Alright, so 147 square root. Okay, so we get a 12.12. So x is equal to 12.12. Okay, so this side here is 12.12 approximate units long. So x 12.12. Alright. Now the converse of the Pythagorean theorem. So if we are given the side lengths of a triangle, we can verify that they are right triangles by proving that the Pythagorean theorem is true for that given triangle. So here, if we set this up, okay, we're going to have 7 squared plus 8 squared, and that's equal to the square root of 113 squared. Okay, so what we want to find is that this is a true statement. By making the Pythagorean theorem true, we prove that the triangle is a right triangle. So let's go ahead and do that. So we have 49 plus 64, and that should equal to 113. Okay, if we add 49 plus 64, we're going to get exactly 113, which we know is equal to 113. So this triangle on the left here, labeled A, is a right triangle because it makes the Pythagorean theorem true. And that's the converse of a Pythagorean theorem. Alright, so if we try that again here, we have 15 squared plus 36 squared, and that's going to be equal to our longest side, or our hypotenuse, 4 square root of 95 all to the power of 2. Sorry, that's a little squish right there, but that's what that says. Okay, so first we're going to do 15 to the power of 2, 15 squared. That's going to be 225. 225. Okay, plus the 36 to the power of 2, which is 1296. And that should be equal to equal to 1520. Alright, so then if we add 225 plus 1296, we're going to get 1521, and that is not equal to 1520. So because these three values did not prove our Pythagorean theorem to be true, then we can verify that this triangle on the left is actually not a right triangle. Even though it was off by just one, it makes it not a right triangle. It must be equal on both sides of the equation to prove that they are right triangles. Okay, last thing that we're going to go over here is how to classify triangles using Pythagorean inequality theorem. So here is where you're going to have to, we're usually going to get something that is not equal to each other. So that is going to give us an inequality setup. Okay, so what we're going to do here is we're going to set up our Pythagorean theorem. Okay, but in this case, we're not going to fill in the equal sign. Instead, we're going to end up writing an inequality symbol for that. Plus b squared. Okay, so here, if we look at our numbers on the right, we have 4.3, 5.2, and 6.1. So C is always the hypotenuse, or the longest side of a triangle. So the longest side here is 6.1. So we're going to put 6.1 squared. Then we're going to do A. A is the shortest leg, or the shortest side, which is 4.3. And lastly, we have B, which is 5.2. Alright, so then what we're going to do is we're going to just start simplifying everything. So we have C first. 6.1 squared is 37.21. Then we're going to square 4.3. That's going to be 18.49. And then lastly, we're going to do 5.2 squared, which is 27.04. 27.04. Alright, and then that's going to be added together to give us 45.53. 37.21. Okay, and this is obviously not an equivalent value. Okay, so obviously we're not going to fill this in with an equal sign, right? C squared does not equal a squared plus b squared. So now here what we're going to do is we're going to fill this in with an inequality symbol. 37.21 is less than 45.53. So our c squared is less than our a squared plus b squared. When this happens, we obtain an acute triangle. When c squared is less than a squared plus b squared, we have an acute triangle. Now, if c squared is greater than a squared plus b squared, then we result in an obtuse triangle. And of course, if we have equal to c squared equal to a squared plus b squared, then we have a right triangle. So this is how you figure out if a triangle is acute, obtuse, or right. Hope you guys enjoyed watching. Let me know in the comment section if you need clarification on anything in this lesson.